Okay, this is the Spring 2013 Common Core AFM exam. We're going to run through it. This is a probability distribution table. We didn't talk about this much this semester, but we have the tools that we need. We've talked about frequency distribution, and we've talked about probability, so we can put the two together. They want to know what's the probability that the house in the community will have at least 3 televisions. One way of writing that is the probability that a household has 3 televisions, or they have 4, or they have 5 plus. So it would be convenient if we could just add up these 3 probabilities here, the probability of 3, the probability of 4, or the probability of 5 or more. Now the problem with that, of course, is that they didn't tell us what percent have 3 and what percent have 4. However, we can figure out the probability that a household has 0, 1, or 2 televisions. And because these are complements, that is to say, if I add up these 3 and I add up these 3, together it's all going to be 100%, because you can't have less than 0 televisions. So it's all going to be 100%. If I want to know this percent, I'm going to take 1 and subtract these guys. So I'm starting with 100%, and I'm going to subtract the probability that a household has 0 or 1 television or 2 televisions. So again, that's going to be 1 minus, okay. Now let's think about this. This is an OR question. You need to ask if these are inclusive or exclusive possibilities. Well, a household cannot have exactly 0 televisions and exactly 1, or 0 and 2, or 1 and 2. So these are exclusive, which means if I want to find this probability, I'm going to add them all up. The probability of 0 is 4%, plus the probability of 1 is 38%. The probability of 2 is 27%. So this is equal to 1 minus, we need to add these up, that's 50, 65, 69%, and 100% minus 69% is 31%. Okay, we are continuously compounding interest. That means we're going to use the PERT formula. 2 people are investing, Anna and Zach. They're both investing $600. They just have different rates of interest. Okay, so Anna, the principal she has is $600. The rate is 10.5%, which we'll write as 0.105. And Zach, on the other hand, he also has a principal of $600, but his rate is much lower, 0.065. Okay, it says, how much will Anna have, or how much more will she have than Zach when his are worth 900? So that means we're going to figure out his balance is going to be 900. So in neither case do we know the time. That's what we're interested in. So we're going to plug this information into Zach's. 900 equals 600 e to the RT. Again, this is A equals PERT for both sides, compound interest. T. So I'll divide both sides by 600. Take the ln of both sides. Of course, ln cancels out the e. And then divide by 0.00. So t is equal to the ln of 1.5 divided by 0.065. That's approximately equal to, we're going to need the calculator. Okay, ln 1.5. I need to turn it on first. ln of 1.5 divided by 0.065, 69% interest, is going to take him 2379 years. So that's T. We're going to plug that in for Anna and see how much money she's going to get. Principal 600, e to the 0.105 times 6 times 2379. Okay, here, 600 e to the power of 0.105 times 6.2379. Since this is in the calculator, I could just hit second answer. Let's see how much money that is. I do want to point out, if you have the calculator where it typically writes the caret, you're going to need to put these guys in parentheses. She gets $1,155, about. So her account balance It's about 1155. His is exactly 900, and therefore she has 1155 minus 900, $255 more. Okay, pH as a function of t is equal to the minus log of t. Okay, it says a sample coffee has a pH of 5. Well, I'm replacing p with 5. And now I need to solve for t. Let's multiply both sides by -1. And how do we get rid of logs? Well, this is a common log, which means the base is 10. So to get rid of a log, you exponentiate, and you give it the base that it already has. All right, 10 and the log cancel out. T is equal to 10 to the -5, which is 0.00001. I know this because I have to move 1, 2, 3, 4, 5 places. So 4 zeros and a 1. Those are your 5 places. Sequence is shown below. What is the sum of the sequence? Okay, there's a couple ways to do this. One is to just kind of add this stuff up. And if you put this stuff in a nice column, so I've got 1. And the next number I'm adding is 0.1. The next number I'm adding is 0.01. The next number I'm adding is 0.001. And the next number is 0.0001. And so on and so forth. What you can see we have going here, your number is going to be 1.11111. That's very clear to see. The calculator is going to tell you that this is about 10 ninths, which is 1 1/9. Hopefully also that you'll see this is a geometric sequence. Every time I move 1 over, I'm multiplying by, let's see, it's going to be 0.1 divided by 1, which is 0.1. There's our common ratio. We divide the second one by the first, gives us the common ratio. And the sum of an infinite series with r less than 1, and it certainly is it's going to be on your formula sheet. Okay, the sum of an infinite series is a sub 1 divided by 1 minus r. In this case, a sub 1 is our first term, which is 1, minus 1 over 1 minus, and our r is 0.1. That's 1 over 0.9. Again, that's 10 ninths, 1 and 1/9. Okay, which statement's true? Well, let's see what kind of sequence this is. If it was an arithmetic sequence, I'd add the same thing every time. 4.5, 4.5. No, it's not arithmetic. Let's see if it's geometric. Well, I'd have to multiply 0 by something to get 4.5, and that's impossible, because 0 times anything is 0. So we haven't got geometric or arithmetic, but let's see if we can find some kind of pattern. It's adding 4.5, then it adds 7.5, plus 4.5, then plus 7.5, and then it goes up 10.5. I'm guessing maybe the next one goes up 13.5. You see like 3 more every time. In any case, it's clearly this is getting bigger and bigger and bigger. It's worse than an arithmetic sequence, and so clearly this diverges, right? The arithmetic series diverge, and so it doesn't converge, it doesn't converge. So it's not A, it's not B. Let's look at the reason why. Now we're talking about limits, and we didn't have time to cover limits. But nevertheless, this is the limit approaches infinity, or is infinity, or the limit is 30. I don't know that anything is limited to 30. I don't think that each term, I think the terms are going to get larger than 30. The sum, let's see, maybe if we add up these, no, if we add up these numbers, the sum is greater than 30. And so I don't know where they're pulling 30. So the answer is C. Again, we don't know. I don't know that I've given you the tools to do this problem perfectly, but you can certainly, have the tools to do it multiple choice. Okay, pharmaceutical company is creating a new cholesterol drug to prevent heart disease. What's the best way to collect data? Okay, well, with medicines, as you know, people do participate in medical studies all the time. That's the way that medical companies have to prove their drugs, is actually doing it, okay? And so simulations and surveys aren't doing it. An experiment is when you control everything, but you don't get to control everything in medical patients' lives. And so what they do is they give people medicine and they observe them. That's an observational study. They observe them as they would be if, in the real world. Okay, exam grades. They want us to compare it looks like means and standard deviation. So we need to compare the mean and standard deviation. So I'm going to use the calculator to do that. Okay, we're on. I'm going to input this information into my lists. I'm going to need clear lists. Actually, I've already got this list in there. 68, 78, 92, 90. Okay, so here's this list. And obviously to find this mean and standard deviation, I'm going to go to stat, calc, first variable stats, or one variable stats, using list 1. Okay, the mean is 80.8, and the standard deviation is 10.3. 80.8, that's the mean, and the standard deviation is 10.3. Okay, and now I'm going to plug in the other information. And you can either plug it in list 2, or you can just cover up list 1. 62, 77, 99, 87, 85, 84, 95, 95, 98, 72, 64, 98, 72, 64. Okay, good. We have the same number. I'm going to assume I punched them in correctly. I'm going to calculate one variable stats, still using list 1, although if I had put it in list 2, I would change that to list 2. Okay, the mean is now 82.3, and the standard deviation is 12.6. 82.3, 12.6. 82.3, 12.6. It looks like they're higher for both the final exam, both are higher. The final exam grades have a higher mean and standard deviation. That's the answer. Okay. Baseball scored the following number of runs in games this season. They want to average them for at least 6. They want to average at least 6 runs a game. How many do they have to get in the final game of the season? Okay, well, let's add up all their runs. 8, 13, 22, 33, 36, 41, 49, 55, 59, 64. So they got 64, although I thought it was 68. 8, 22, 33, 42, 56, 68. Yeah, 68. They've got 68, but they've got one more game. So to this 68, we have to add the number of runs they get in the last game. Now, that's what they're asking us about. What is the least number of runs they must get in the final game? So it's 68 plus the final game. And to get the average, we're going to divide this by the number of games. Well, 3, 6, 9, 11. They played 11 games, but their final game is going to make 12. And they want at least 6 runs, so that's going to be greater than or equal to 6. We just have to solve for x. Let's multiply by 12. 68 plus x. Multiplying by 12. Subtracting 68. You have to get at least 4. Okay, the probability of giving birth to a boy. What's the approximate probability of giving birth to 4 consecutive boys? So this is a probability of a boy, and a boy, and a boy, and a boy. Okay, so we're going to assume that these are independent events, that having a boy the first time doesn't affect your chances of having a boy the second time. Since these are independent, I'm just going to multiply it. Well, the probability of a boy, it's not 1/2 like I was about to write. It's 52% apparently, times 52%. Times 52%, times 52%. An easier way to punch this in the calculator would be 0.52 to the power of 4. And I can't remember exactly what it is, so we'll use the calculator real quick. 0.52 to the power of 4 is 7.3. How many more ways can 10 jurors running for the positions of this, and this be selected when compared to 12 sophomores running for? So we've got two ways. We got juniors on this side, sophomores over here. Okay, there are 10 juniors, and they're running for 4 specific offices. So the order we pick these in is going to make a difference. Since the order matters, and these are dependent, by the way, because if you pick one student, you can't pick him or her again. So it's dependent. The order does matter, so this is a permutation. I have 10 people to choose from, and I've got 4 positions, so I'm going to do that permutation. The sophomores, on the other hand, there are 12 of them, and they're running for 5 positions, but their order doesn't matter, because everyone picked is going to be a representative. It's the same thing, so that's a combination. So let's compare these two. We'll start with the juniors. Okay, so math, probability. We're doing a permutation. Oops, I forgot to put a number in first. The number we're going to put in is 10. Oh, and there I covered it up. 10, and we're picking out 4 of them. That's 5,040. We do a combination for our sophomore class. Choose 5. 792. So we've got a lot more choices for the juniors. We subtract here, we've got about, I don't know, 4,200, 4,248. That's it. Starting line for hockey team, we need 3 offensive players. We need 2 defensive players and just 1 goaltender. Coach has this many of each. How many unique ways? Well, let's think about how many ways he has to choose offensive players. In this case, we're not distinguishing between left wing and right wing and whatnot. So it seems to me that we're making a combination. From offensive players, he has 11 to choose from, and he's picking 3. For defensive players, again, it's another combination. They don't tell us left side or right side. So we're picking between 6 defensive players, but we're going to pick 2. And for 1 goal, well, I mean, it doesn't matter if the order matters or not because there's really only 1 position. We can call it a combination or permutation. We're picking from 3 different goalies. Oh, I'm sorry, 2 goalies. We've only got to pick 1. So let's plug these all into the calculator. 11 choose 3. 11 math, probability. Choose 3. 165 ways to choose an offensive lineup. 6 choose 2 is, that's just 15. And then 2 choose 1 is just 2. So these are independent of each other. I want to convince you of that. Because which offensive players you pick has no effect on which defensive players you pick. So because these are independent, it's basic counting principle, we're going to multiply all of these. And as you'll see, that's 4,950 ways. Okay? So we're talking about a pie. How much money a bakery can expect to make on a pie. Well, first of all, we need to figure out how many options we have here. The first is selling it on the first day. Okay, maybe they sell it on the second day. Or maybe they give it away. That's after 2 days they donate it. Okay, so for each one of these, we need to figure out what the profit is. How much money are they going to make? And we need to figure out the probability of that happening. So on the first day, they're going to sell it for $12, but it costs them $3.50 to make, so their profit is $8.50. The probability of that happening, see, the probability of selling on the first day is 75%, so 0.75 is the probability. Okay, let's look at the second day. The new price on the second day is $8.50, but again, it made them $3.50 to make it, so their profit's only $5, and that's a 12% probability. Okay, and then maybe they donate it. If they donate it, they're not going to make any money, but it costs them $3.50, so they're losing $3.50. And let's see, well, that's 87% chance. If they don't sell it, there's a 13% chance. That means there's a 13% chance. Okay, so what I'm going to do is I'm going to multiply each of these by the percent probability, and then I'm going to add those up. So let's just do that. Okay, so we got $8.50. There's about a 75% chance. So we're going to add to that $5 times the 12% chance that they sell it on the second day. And finally, we're going to add, actually we're going to subtract $3.50 times the 13% chance that they donate the pie. $6.52. Okay, we're going to call that the expected profit per pie. Okay, this is a problem we had difficulty with the other day. And what I want to do is simplify the problem. This is probability, so these are percentages. What I want to pretend is, instead of percentages, these are the number of houses in Cityville that have this number of occupants. Okay, so for example, for this case right here, I want to pretend that there are 21 houses out of 100. There are 21 houses that have one person in a single person household, and I want to pretend that 28 of the houses have 2 people in them, and I want to pretend that 16 of the houses have 3, and so on and so forth. So what I'm going to do is I'm going to add up the total population So the expected size of household is going to be the population of Cityville divided by the number of households. That's going to give you the people per household. No, I'm just going to okay. So let's get that population. It's going to be, well, 21 times 1. I'm going to add 28 people, 28 houses that only have 2 in them, plus so on and so forth, blah, blah, blah. And then I'm going to divide by the number of households. Well, since these are really percentage points, they're going to add up to 100. Dot, dot, dot. And the last one's going to be 0.01, or just one house and 8 people in it. So let's get the calculator and add those up. Don't need to really write all that out. So we're going to start with the 1. There are 21 households that have 1 person in them. So that's 21 people. And then there are 28 households that have 2 people in them. So that's 56 people. And there are 16 houses that have 3 people in them. That's 48. And there are 22 houses that have 4 people in them. Okay, so 22. And then there are plus the 6 houses that have 5 people in them, plus the 4 houses that have 6 people in them, plus the 2 houses that have 7 people in them, plus the 1 house that has 8 people in it. So that gives us a population of 289 people. And there are 100 households. So the average is 2.89 people per household. Okay, we're going to expand. This is binomial expansion. Okay, we only care about the middle term. Well, if we're choosing 12, the middle term is going to be 6. So it's going to be something, something, something plus, and then we get to our 6th term. To find the coefficient, we always use a combination. The larger number is that of how many trials we have, if you will. And since we're choosing the 6th term, we're going to pick 6 there. And now we're going to take each one of these terms. The first one is x squared. It goes first. And since we're choosing 6 of those, we multiply it to the 6th power. The other option is 3. We're going to raise it to the power of 12 minus 6, which is also 6. Okay, and then we don't care about the other terms. Just this guy right here. 12 to 6. Let's plug that in the calculator. 12 math, probability, NCR 6. 924 is the first number. Okay, x squared to the 6th, power to a power, you multiply. And then finally we have 3 to the 6th. You might think we already have the answer. It's right there. 924, but let's go and do 3 to the 6th. That's going to be our multiplication on the back end. 729. If you multiply 729 times 924, you get this number right here. Okay, an 8-question multiple choice quiz. Probability of answering any question is 75%. What are the chances that she gets 2 wrong? Okay, this is a binomial experiment because there are 2 possibilities. She gets each problem right or she gets it wrong. And there are 8 questions, so there are 8 trials. Now we want to know the probability that she gets exactly 2 wrong, so 2 W's. All right, well again, the coefficient is going to be, we're going to have to do a combination. There are 8 trials, and we want to get 2 of something, so we're going to choose 2. Now you might say, oh, we need to choose 6 rights because the rights go first. It does not matter. 8 choose 6 and 8 choose 2 are the same thing, actually. Okay, right, we have right going first. Now this is important. Her chances of getting a question right for any one of them is 75, so we're going to call that. But in any case, if she gets 2, I'm getting ahead of myself. If she gets 2 wrong, that means she gets 6 right. Then we put the second variable, we're going to get 2 of those. Okay, 8 choose 2 is 4 times 28. Chances of getting 1 right is 0.75. We're going to raise that to the 6th power. Chances of getting 1 wrong, well, if she gets 1 right 75% of the time, she gets 1 wrong 25% of the time. We're going to square that. So again, to the calculator, 28 times 0.75 to the power of 6 times 0.25 to the power of 2. It's about 31.1, rather. Okay, which function results and shifting this 4 units to the left and down 3. Okay, down 3, that's vertical. That happens on the outside. And we just subtract 3 to move it down. Well, minus 6 minus 3 is going to be minus 9. No, it's one of these guys. And if I'm moving it to the left, it happens on the inside because it's horizontal. And remember, stuff on the inside is usually backwards. So the left, we think it's subtracting 4, but it's actually going to be adding 4. And 3 plus 4 is 7. So it's going to be one of these guys. Well, it has to be A. Which piecewise? I know you love the piecewise functions. Which one's graphed below? Okay, what's the best way to do this? Let's graph. We're going to use the calculator. I'm going to assume that you're going to run to that. And let's just look at negative 2x minus 7. Now, we've talked about how to plug these in, but it's really complicated. So let's just look at it one part at a time. Negative 2x minus 7. Let's graph that. Okay. So that's one part of the graph. Does any part of the graph look like that? Is that maybe this guy? I think it might be. I think it might be. Well, let's see. They say for x is less than negative 5. Here's negative 5. That would mean for over here. That looks like it could work. So maybe this works. Maybe. Okay, what does this guy say? He says the same thing. Well, that's looking pretty good. C, negative 2x minus 7. It says less than or equal to. But that's an open circle. So this one is wrong. It's not C. Let's look at D. He also says less than or equal to. That's wrong. Okay, we've already narrowed it down to 2 just by looking at that. So that's easy enough. Maybe without even graphing the rest, we'll just look. This right here says negative. Okay, those are exactly the same, What's different about these two choices? I think the only difference is this sign right here. Okay, there's a couple ways to do this. One is to think about this. The parent graph of this middle part is x squared. And so to get there, obviously that's going to turn it upside down. The 6 is going to move it up 6. That plus 2 is going to move it to the left 2. This plus 2 is going to move the vertex to the right 2. So the vertex has been moved to the left 2. I know it's this one right here. So it's A. Okay. But even if you weren't sure about that, we've already narrowed it down to A and B. So you just do the one part that's different. Let's graph the one part that's different. Clear. Okay. So I want to check to see, is it negative x plus 2 squared plus 6? Or is it going to be negative x minus 2 squared plus 6? So everything's exactly the same for that, except for that sign. I'm going to go ahead and make this one thicker so I can tell the difference. I want to see which one's right. Okay, that looks good. That looks like what I have. I don't like that one. It's to the right. It should be to the left. To the left. That was the first one, so the answer is A. Okay, function shown below. What's the range of this function? Okay. All right. Let's see if I can remember how to graph this on the fly. We're going to graph this all as one function. Okay, the first part, I'm going to put in parentheses x minus 4. And I can tell it when to do this. I have to put in parentheses 0 is less than or equal to. I find that under the test menu. Test less than or equal to is 6. 0 is less than or equal to x. And then I have to combine this. I have to use and, which I'm also going to get from test logic, and x is less than 2. I know it seems silly. It seems like you could write it all as one, but you can't. You have to write it separately. X is less than 2. Okay, that's the first part. And then I have to write a plus sign, and then I can write the second part of the function. It's this quadratic. X squared minus 3x plus 4. Close that off. When is that true? It's true for 2 math. I'm sorry, second test is less than or equal to x. X is less than 4. Again, I have to connect this with and. Second test logic, and x is less than 4. Second test less than 4. Close that off. Plus the final leg of this is just 5. And that's true when 4 is less than or equal to x. Second test less than or equal to x. And second test logic. And x is less than 7. X is less than 7. Finally, let's graph that thing. Hopefully it'll all show up and I won't have to mess with the window. Okay, there's our function right there. They want to know, what is the range of this function? What is the range? Okay, this doesn't look familiar with you because we typically just used, this is interval notation. We used to set builder notation, but that's okay. So we know that it goes, y has to be between, it looks like the lowest it gets -4 up to 2. So we'll say that -4 is less than or equal to y is less than, let's see. The -4 happened at the end where it's or equal to, and this happened where it's not equal to. So that's part of it. And the other part is, looks like it starts at +2. It goes up to 6, 8. It goes from 2 to 8. This part does not play in really. It doesn't add to it. So 2 to 8. Okay. And it was all this guy right here for the middle part. So it should be closed here, but it does not include the end of the line. So that's our, let's see what that looks like. -4 to -2, -4 to -2, that's right. 2 to 5, 2 to 8. Well, clearly this is the answer. Now, just so you know, the bracket here means equal to. The open parentheses means not. Bracket means or equal to. Open parentheses means not. So we're good. No surprises there. Okay, a water tower is located 410 feet from a building. Sounds like a trig problem. Got a water tower, and we've got a building. Okay, 410 feet away, so that's this side right here. From a window in the building, it is observed that the angle of elevation to the top of the tower is 42 degrees. So you measure angle of elevation between the horizontal and the line of sight, so that's 42 degrees. And again, this side is 410. The angle of depression to the bottom of the tower is 25 degrees. Oh, this is ugly. How tall is the water tower? This is a difficult problem. Okay, 25 degrees down. Okay, how tall is the water tower? Well, we've got two different triangles here. What we want to do is measure this part of the height, which I'm going to call A, and then we're going to add that to this part of the height, which is B. Okay, so let's find A first using the blue pen. It's going to be A and 410. That's opposite and adjacent. So I'm going to do the tangent of 42 degrees equals the opposite side over the adjacent side. So A is going to be 410 tangent 42. And that is approximately 410 tangent 42. 410 tangent 42. You want to make sure you're in degree mode. 369 feet for that part. So we think it's B, but no, it's not. We've got to add the bottom part. So we use red. Again, let's see. This is 25. This is not inside our triangle. So we can either say this is 25 degrees because they're alternate interior angles, or we could say this guy right here is 65 because they add up to 90. I'm going to go with the 25 down here. So the tangent of 25 equals the opposite side over the adjacent side, and B is 410 tangent 25. 410 tangent 25. 191 feet. Another option, and we probably could have guessed that. Add these two together, and you get 560. Given the table below, which fits the data. All right, there's two ways to do this. One is we can plug in the x's and see if we get the right y, or the other way to do it would be to plug this data in and run a sine regression. So let's try, I think the easiest way would be just plug in the information. Okay, so I'm going to do 0.5. Oh, by the way, since we're talking pi here, now we have to make sure we're in radian mode, not degrees. Okay, 0.5 cosine of 2 times x, and we'll start with pi over 2. Pi over 2, 2 times x minus pi, and that's it. It should equal 0.5. Let's see. It equals 0.5. So this guy works for the first one. I'll put a check underneath it. Let's try and see if it works for, let's work for the next one. It's going to be exactly the same. Or we'll go to 3 pi over 4. I'm trying to be lazy about this. Okay, instead of 2 times pi over 2, I'm going to 2 times 3 pi, insert 3, 2 times 3 pi over 4 minus pi. That's essentially 0. So far, so good. Now we want to plug in 1 pi, 2 times 1 pi. So to keep that easy, I'm just going to say 2 times 1 pi over 1 minus pi. Negative 0.5. I think we have a winner. I'm going to go ahead and work out the rest. 5 pi over 4. So instead of 1 pi over 1, I'm going to do 5 pi over 4. 0. Now let's check the last one. 3 pi over 2. 0.5. Yep. Okay. In the interest of time, I'm going to go ahead and circle that. Maybe I'd come back to it and check it out. But that satisfies me. Okay, Ferris wheel. Diameter is 80 feet. You enter at the lowest point, 5 feet above the ground. So this is 5. And this is 80. At time t equals 0, 1 complete rotation takes 65 seconds. Well, 65 seconds then is going to be the period. Period equals 65 seconds. All right, which function models the vertical height at t seconds? Okay, notice we have no phase shifts. So that is to say that we start right at the beginning. Which one of our functions, let's see, sine looks like this. Sine of 0 is 0. It's going up. That's the sine function. Cosine function starts at 1 and goes down. So that's cosine function. Negative cosine is the one that starts upside down. So negative cosine is what we need. Negative cosine, negative cosine, negative cosine. Okay, so they're all negative cosines. That's great. Glad to confirm that. Okay, let's see. This number out here is always the midline. Okay, well, the midline is going to be halfway through here, right? So that's going to be 40 feet from the bottom of the circle plus the 5 there. So we need to add 45. We've already got the answer, and we didn't even have to figure out the period. Let's go ahead and do that real quick. The period, which is 65 in this case, is always equal to 2 pi over b, where b is the number you multiply t by. So if I multiply both sides by b and divide by 65, I get b should be 2 pi over 65. Yes, that's right. Okay, very good. Didn't even have to worry about the amplitude, although that's obvious. It goes up 40 and down 40. So very good. On all 3 counts, we're right. I guess 4 counts. All right, how do we compare the graph of 0.5 cos to the 2x from just the plain old cosine x? How does g compare to f? Okay, well, f is cosine. I can immediately see that the amplitude is 0.5. So it's going to be, instead of going from 1 to 1, it's going to go from 0.5 to 0.5. So the amplitude is smaller. Okay. And the period is longer or shorter. Well, there's 2 ways to do this. One is to graph it, but we don't have to. Look, f, the b, the number in front of x, is 1. So f's period, the period of f, is equal to 2 pi over 1, which is 2 pi. And g, the one we're interested in, period of g, 2 pi over, its b is 2. 2 pi over 2 is 1 pi. So its period is only 1 pi, where f's is 2 pi, so its period is shorter. The answer is A. But even more to go. 2 sides of a triangle are 14 and 17 respectively. The included angle is 72. How long is the third side of the triangle? Well, this is not a right triangle, so I'm going to be interested in using the law of sines or the law of cosines. And this is 17, 14, 72. I do believe in the case of side angle side, we said we'd use the law of cosines. They do provide the formula sheet, but we'll need to know when to use it. Let's say this is side A, this is side B, and this is side C. This would be angle C. And I'm going to use the law of cosines. I know that C squared is equal to A squared plus B squared minus 2AB cosine C. So again, I don't know C, but it's going to be 14 squared plus 17 squared minus 2 times 14 times 17 cosine of 72 degrees. Back to the calculator. Make sure it's in degree mode. I think I put it in radian earlier. It's in degree mode. Second quit. Okay, so it's 14 squared, which is 196, plus 17 squared, which is 289, minus 2 times 14 times 17 cosine of 72 degrees. Close it off if you'd like. 337.9. How long is the other side? Well, we have to take the square root. So square root of the answer. Square root, second answer. About 18.4. More to go. Geometric series. Sweet. They tell us A1 and R. What's the approximate sum of the first 20 terms of the sequence? Let's get the formula sheet. Oh, wait, real quick. It's a geometric sequence, and they want to know the sum. Okay, let's look for that. The first 20 terms. So, geometric sequence, the sum of the first 20 terms. A sub 1, 1 minus R in, 1 minus R. Okay, so the sum of the first 20 terms is going to be A sub n, I've already forgotten. A sub 1, 1 minus R to the n. A sub 1 times 1 minus R to the n over 1 minus R. I'm going to check one more time to make sure I got that right. Yeah, where R is not equal to 1. R is not equal to 1, it's the square root of 2. So we're going to plug this in. A sub 1 is 12. 1 minus R, which is the square root of 2, to the power of n, well, it's to the power of 20, over 1 minus R. Okay, we have to be careful plugging this in the calculator, but again, this is quite easy. 12 times the square, 1 minus the square root of 2, go outside to the power of 20, get down, close off the parentheses, that's the top, divided by, we've got two terms on the bottom, so we need to use parentheses, 1 minus square root 2. Oops, I'm used to using the other one. Let's get outside, close parentheses, 229,636.9. That's the last one. Bathroom floor has tiles arranged in 9 circles. The innermost circle contains 9 tiles. So we've got 9 circles. 3, 4, dot, dot, dot. Right? The innermost has 9. Each successive circle contains 9 more than the previous. How many total tiles? Well, let's think about this. I've got 9 in the first, and I've got 9 more than that in the next. It's 18. Plus 9 more is 27. Plus 9 more is 36, and so on and so forth. I could actually, if you forgot how to use the formulas, again, they provide them. If you forgot how to use the formulas, you could easily just plug this in yourself. So we've got 9 circles. How many tiles are on the bathroom floor? Okay, so this is, I hope you see, an arithmetic sequence. I add the same number. I add 9 every time. So it's an arithmetic sequence. I don't know how many total tiles. That's the sum. Let's see. It's a sum of how many numbers. Well, it's 9 circles, so that's going to be 9 numbers. And the formula is n over 2 times a sub 1 plus a sub n. Oh, well, n is 9. I need to go back and replace the n's with 9s because we're talking about 9 circles. Before I can plug this in, I need to figure out what the 9th term is. I'm going to use the formula, which they provide for me. It's an arithmetic sequence. A to the n is that right there. Just plug this in. A sub 9 is the first number, a sub 1, which is 9, plus n minus 1, that's 9 minus 1, times the d, the common difference, which is also 9. So this is going to be 9 plus 72. 81's in the last. Okay, so 9 over 2 times 9 plus 81. 45 times 9, 360, 405. You might have done that faster if you had just plugged in the first 9. In any case, we are done.